Hello and welcome to this Vivado Quick Tech video where we'll be discussing how to program and debug your design using Logic Debug IPs and Vivado Logic Analyzer tool. Here's what we'll learn in this video. We'll explain different features of Logic Debug in Vivado, learn how to add Logic Debug IPs to your design, and also demonstrate how to use Vivado Logic Analyzer to debug your design. Debugging logic in FPGA designs is generally a multi-step and iterative process. Even though reconfigurable nature of FPGAs makes the design iteration easier, it is highly recommended to plan out your debug early in the design cycle. Break complex designs into smaller and manageable parts, and follow a logical approach to simplify the problem and predict the results. Vivado provides various debug IP and tool features that enable you to easily debug your design while it is running in hardware. This is effective because you debug your timing accurate and post-implemented design in the actual system environment and speeds. Multiple debug IPs can be used to debug the logic in your design. ILA or Integrated Logic Analyzer can be used to trigger on hardware events and capture data at system speeds. VIO or Virtual Input-Output can be used for monitoring as well as driving of internal signals, and jtag-to-axi to directly interact with AXI interfaces via Tickle. In order to add these IPs to your design, there are intuitive debug flows and methodologies that support Netlist insertion and/or HDL instantiation of debug IPs. In addition, there's support for identifying debug nets in your design and preserving them during synthesis and implementation. Once debug IPs are added and implemented in your design, you use Vivado Logic Analyzer to interact with Logic Debug IPs. Logic Analyzer provides you with an easy setup for taking measurements and capturing data using customizable dashboards. You can also analyze the captured data through configurable waveform viewer. Now let's find out how we enable your design for Logic Debug. First, you should decide how to add Logic Debug IP to a design. One method is to use HDL instantiation flow. Similar to addition of any other IPs to a design, this flow involves the manual customization, instantiation, and connection of debug IP instances directly in the HDL design sources. This flow is flexible and predictable, but it could be error-prone and it requires modification to the HDL sources. But if it's the right approach for your design, you should take the following steps. First, you customize and generate the debug IP in the IP catalog. For example, you select the right number of probe ports for the signals you want to probe. Then, you instantiate the IP in your design and provide the connectivity for each of these probes. And lastly, you proceed to synthesize and implement your design containing the Logic Debug IP. Let's have a look at these steps in the tool. Once within the project, first open the IP catalog. To find the IP that you need, you can either do a search or find the Logic Debug IP under the Debug and Verification category. Here, let's say we want to add an ILA IP. Select and double-click to customize. Configure the ILA IP by giving it a name. Here we call it My ILA. Select the number of probes. We want to have 2 probes here. And configure any of the other settings. For example, we change the data depth to 2048. And finally, we set the width of each probe, 3 and 8, for example, in this case, and hit OK. Next, you have to make a selection for the synthesis of the IP, and the recommendation is to use out of context. This option will synthesize the IP separate from the rest of your design and significantly reduces the time to synthesize your design. Notice that an out-of-context run is launched. As this will be used for implementation, no time for the synthesis of the IP will be added to the synthesis run of your design. Now that the IP is created, you can instantiate and make the necessary connections for it. There are instantiation templates among the IP-generated files that you can use. Let's go to the source file where we'll instantiate the IP in. When you instantiate the ILA, you would want to connect the probes to signals that are all within the same clock domain. You also connect the clock signal of that clock domain to the IP. Once this is done, you can proceed to synthesis and implementation of your design. Remember that these steps for the instantiation flow are the same for adding any Logic Debug IP to a design. Another way to enable your design for Logic Debug is called the insertion flow. Notice that you can only use this flow if you decide to add an ILA IP to your design. To do so, you need to first synthesize your design. Then, the easiest way is to use Setup Debug Wizard. It's a simple wizard that automatically creates and configures ILAs based on the selected set of nets to debug. As shown here, this option is present only when you open your synthesized design, and the wizard takes you through a number of easy steps to configure the ILAs. This flow is recommended because the tool automatically creates the connection between the probes and debug nets for you. If more control over the individual ILA settings, ports, and configuration is needed, then you can use the debug window. This window gives you an overall representation of the existing debug cores within the design and allows you to add, remove, or modify ILA cores. Even if Setup Debug Wizard is used at first, you can still use Debug Window to further change the ILA settings and connectivity. To benefit from the automated features of the insertion flow, you can identify the signals you intend to debug before or after synthesis. Vivado synthesis feature allows you to optionally mark HDL signals for debug using the Mark Debug attribute in both VHDL and Verilog source files. In addition, you can mark nets for debug in different parts of the GUI, where they get eventually stored in the target XDC file. Marking nets for debug not only directs synthesis and implementation to best preserve the signals, they are also used in the Setup Debug Wizard and Debug Window GUI for helping you to easily find the debug nets. Let's have a look at all of these features in the tool. To use the insertion flow, first you need to open the synthesized design. Now that the synthesized design is open, notice that you're in the debug layout where it has the debug window open by default. Let's mark some signals for debug first. We can use the Netlist window by right-clicking on the nets in different hierarchies to mark them for debug. You can also select nets in the schematic viewer and right-click for Mark Debug. Notice that any nets that correspond to HDL signals that were marked for debug are shown in the unassigned debug nets folder in the debug window. Next, open the Setup Debug Wizard and click Next. In this dialog box, you can add more nets or remove the existing nets from the table. Note that the nets we already marked for debug are present here and there is no need to add them. In addition, you can add nets by selecting them in the Netlist window as well as drag and drop into this window. Next, we select the clock domain to be used to sample value on the net. The wizard attempts to automatically select the clock domain, but you can modify this selection as needed. You can choose the desired features and add the ILA IP to your design. The Debug Cores tab in the Debug window provides more fine-grained control over ILA insertion than what is available in the Setup Debug Wizard. Similar to Instantiation flow, you have full control over the settings in the Debug window, but you should create all of the required port connections manually. Let's remove and add an ILA here. Create Debug Cores button on the left adds an ILA. You can select the desired name and options and add the ILA. Once added, you can create additional ports and connect all of them, including the clock port, manually. For example, you can right-click on a net in the Netlist window or schematic view and select Assign to Debug Probes. You can also use drag and drop to make a connection. You can also change the properties of the debug IPs. First, select them in the debug window, and then in the Cell Properties window, select the Debug Core Options view to modify the properties. Once you save your project, all of the information related to the insertion steps are stored in the XDC file, and therefore, there is no need to repeat any of these steps. Now that the addition of the Logic Debug IP to the design is complete, you can proceed to implementation and bitstream generation. Note that during implementation, the debug IPs and debug hub, which acts as an interface between the JTAG interface of the FPGA and the debug IPs, are created and integrated with the rest of the design. Once you have added Logic Debug IPs to your design, Vivado Logic Analyzer enables you to interact with them. This is done by a number of different windows, such as trigger, status, or waveform window that are associated with each debug IP in the design. To help you view and manage these various windows, dashboards fill up the workspace area and enable you to create, modify, and save the layout of windows in your debug session. Let's see how it works in the tool. Once the bitstream generation is complete, open the Hardware Manager to connect to a hardware target. Select Local Server if your target is connected to the same machine on which you are running Vivado, and Remote Server if your target is connected to a different machine. Select the appropriate hardware target from the list of devices present in the JTAG chain. To program the device, associate the bitstream and probes files with the device. If you're working within a project, these files have already been selected for you, otherwise you have to provide the location of these files. And program the device. After programming the FPGA on a hardware target for the first time, the tool automatically detects the debug IP within your design and creates a set of default dashboards for you. As you see here, a number of different debug IPs are present in this design, and there is a separate dashboard for each of them. Each ILA dashboard contains the setting, status, trigger setup, and capture setup, as well as the waveform window of that ILA. You can add probes to trigger setup, capture setup, waveform, and VIO probes windows. This is easily done by clicking the green plus button in these windows and selecting the desired probes. Notice that only the probes for that particular ILA or VIO are listed in the Add Probes window. Let's add 2 probes to the trigger setup window. Set the probe's trigger condition to the condition that you want to test for. Set the value to compare against using the radix selected. Now we're ready to arm the ILA. Arming a core simply means that the core is made ready to collect incoming signals. Before we do that, note that you can always click the Run Trigger Immediate icon to capture whatever data is currently presented to the specified analyzer core, despite the trigger conditions. This is useful if you only want to see the activity on an ILA or VIO without having to set or modify the trigger conditions. After a short delay, data will be uploaded from the device and displayed in the waveform viewer. To capture data when the specified trigger condition is met, you click the Run Trigger icon. You can see the status changes to waiting for trigger. Here, the trigger condition is dependent on an assertion of an input of the VIO IP in this design. Typically, the windows in the default dashboards should be enough to debug your design and view the results. However, there are times when you might want to move windows around and customize your dashboards. For example, here you may want to be able to view both the ILA status and waveform windows in addition to controlling the VIO probes in the same dashboard. Use the Slide Out button on the left side of a dashboard to open its option settings to select the windows that appear on the current dashboard and easily include the VIO window in this dashboard. Now let's add the proper VIO probes and assert the probe to meet the trigger condition for the ILA. Once asserted, the trigger condition is met, and you can now analyze the captured data in the waveform viewer. It's important to note that when you work within a project, all of your programming and debug preferences and settings are saved on disk. This gives you the ability to easily resume your debug work at a later time with your settings and configurations already in place. In summary, we showed you how to enable your design for Logic Debug by adding the debug IPs using the insertion or instantiation flows, and we demonstrated how to use the Vivado Logic Analyzer. For more detailed information, you can look at the Programming and Debug User Guide as well as the Design Methodology Guide. Thanks for watching this Vivado Quick Take video.
Thanks for viewing this quick take. If you found this video useful, you might be interested in taking some of our more in-depth training available at xilinx.com/training. We feature a variety of courses, both live and online, intended to make you proficient with Vivado and its features. We look forward to your participation. Thanks again for making Vivado successful.